Hello everyone. I realized that I screwed up on my times. So I said, you know what? I told people I was going to be here at 1 o'clock. Well, then guess what, boo-boos? I'm going to be here at 1 o'clock. So, hi everyone that's coming in. My name is Audrey Codner, and I am the founder of ACG Math Tutoring. And I was going to work on proportions today. And then I came to a realization that there is one thing that a lot of students are still struggling with, and it is solving equations. So let me turn this down just a hair because I had my headphones on. And if you're here, go ahead and just say hi, introduce yourself. Welcome on in. So as I mentioned, today we're going to solve equations, but we're going to solve what's called one-step equations. Okay, today's date is 2/10 and it's 25. It's kind of funny that 10 divided by 2 gives me 5 and 5 squared gives me 25. I can't turn it off, guys. I can't turn it off. So, all right. So what we're going to be doing is working on what's called an equation. So in order for us to do our equations, I'm feeling pretty okay. In order for us to do our equations, we have to know what's called an inverse. So the inverse is basically your opposites. So if you have, I'm not going to do anything. If your equation is positive, that means that inverse is going to be negative, and vice versa. If your equation is showing multiplication, which I like to show parentheses for that, if it's showing multiplication, that means the opposite of multiplication is division. Now, if you ever look at a division sign, division is nothing but a fraction. It's a number over a number. The dots are supposed to represent numbers. All right, so I am not really into co-hosting for my things, so thank you for dropping in. All right, so if you understand the inverses, so the inverse of plus is minus, the inverse of minus is plus, and vice versa. The inverse of division is multiplication, and the inverse of multiplication is division. So once you get this down, you can solve equations. So the main thing that you need to understand is when you are using your inverses, you're trying to do, so I want to say the goal for solving equation is to isolate your variable. Okay, so when you isolate the variable, that means you want to get your x by itself on one side of the equation and then get all the other stuff on the other side of the equation. So what I mean by that, so I'm going to use my first example. I'm going to put it right here. So my first example I'm going to have is 3 plus x equals, 7. So this is my equation. If I didn't have that equals and a plus 7, that means this would be an expression. So we don't want an expression. So I'm going to do that. Okay. When we have an equal sign, that's going to be an equation. If there isn't an equal sign, it's called an expression. So we want to find out what this unknown variable of x is. So we want to get x by itself on that same side of the equal sign. So I like to think of the equal sign almost like a wall, like a barrier. So if I want to keep x right where it is, what needs to go on this side so my x can be by itself? I feel like it's almost like a life lesson. Like this person is trying to add themselves into your life and you're like, no, I want to be by myself. I want to be independent. So that means this 3, and you always look for the signage in front of the number. So if I don't see anything there, that means this is a positive 3. So the opposite or the inverse of a positive is a negative. So in order for me to even things out, I need to subtract this person out of my life. But not only out of my life, but put them over here, over on this side. Okay? So when I do that, my 3 minus 3, that will give me 0. So I don't need the 0 as a placeholder because I still have this positive x over here. So I'm going to bring that down, and I'm also going to bring down the equal sign. So now I'm going to look over here. I have 7 minus 3. I have $7. I want to spend 3, so that means I will have how much after I spend it? A total of 4. The reason why they call this a one-step equation, because I'm just doing the inverse one time so I can get my x by itself. Hello. All right. So when we're doing these, we have to think of our inverses. This is vital. Okay, have to remember the inverses. So if I have another example, I'm going to put it over here. So my example number 2, shift this over a bit. So if I have x plus 2 equals 20. So again, the equal sign is my wall, is my barrier. So I want to keep x right where it is because I want it to be by itself. So the x is you. I want to be independent. I want to be by myself. But here comes 2 trying to mess everything up. So now I got to get rid of this person out of my life. So I have to do the opposite of what attracted this person to me. So I'm going to do the opposite. So since it's a plus 2, I need to do the inverse, which is minus 2. So I'm going to subtract 2. Whatever you do on one side of the equal sign, you must do on the other side of the equal sign. All right. I'm trying to see comments. Hold 1 second. Let me see if I can slide this bad boy over. That just shows how many people are joining, so that doesn't help. Okay. Hey, Mike, how are you? All right. So now I have 2 minus 2, which gives me 0. So I don't need that 0 as a placeholder because I also have the x over here. So I'm actually just going to bring down my x, bring down my equals. So now I got 20 minus 2. So they're like terms, so they're getting along just great. So I have $20. I want to spend 2. How much money do I have left over? So I have 18. Okay. All right. And you always want to kind of box your answers. So let me see if I can expand a little bit. Maybe that might help a lot so we don't have to be like straining to see stuff. Okay. There we go. A lot better. All right. So this is with when I'm doing subtraction. So now let's see this example. Example 3. So this time I have y minus 8 is equal to, let's say, 15. So I have y minus 8. Again, my equal sign, it's a barrier. And I want to isolate my variable. And my variable right now is my y. So y, that's you. You want to be independent by yourself. But then here comes -8. Okay, trying to bring his or her negativity into your world. So you are trying to retract that. So you want to do the opposite. So if I come up here with my inverses, I have a negative. So we know that the inverse of a positive is a negative, but guess what? The reverse happens as well. The opposite of a negative is a positive. So now I'm coming down here with not only a -8, I do the opposite. I'm going to add 8 to both sides. Okay, thank you for popping in. So if anything, we have -8 plus 8. So I want to spend $8. I have $8. That means I don't have any left over. So these are my 0. But I don't need to put the 0 down because on the same side of the equal sign, I still have this y. So I'm going to bring this y on down, as well as the equal sign. So now I'm actually taking a look to see what is 15 plus 8. So you have your 3, carry your 1, and you have your 2. So y equals 23. So the reason why we're doing all this is we want to know what number I can substitute in for y to make this equation into a true statement. Because I know if I plug that 23 into the y and subtract 8, I will get 15. If I wanted to plug in my 18 for the x, I know 18 plus 2 will definitely give me 20. And if I wanted to plug in the 4 for this x, 3 plus 4 will definitely give me 7. So the reason why you're doing all this, because I don't think some people don't tell you guys, is so you can figure out what unknown number will make the original equation true. That's why you're doing all this, okay? X does not represent 1. It is 1x, but x, the value of x itself never just represents 1. Okay, it could represent any number. Okay, so that's kind of looking at it through adding and subtracting. So I kind of want to pull our favorite thing in the whole wide world. I want to pull a word problem. And you're probably like, oh, good God, why? We were cool, Audrey, and now all of a sudden you want to tamper our coolness. Yeah, all right? So instead of, this is what I would generally do if I have my own classroom. I will have my students kind of tape these in. I'll just usually get like cut and paste and just have them kind of tape it all in there. Okay, still nice and neat. Keep it nice and flat. I might put another quick little piece of tape in here, like up here, just to keep it safe and secure. All right. Well, hello. Thank you so much. Welcome in. Love the love. All right. So now, Maddie has X dollars. After spending 90 on a purse, she will have $45. What is the value of X? Now, we always see word problems and right away our pressure goes up because we're like, well, I don't know how to translate all this into stuff. All right, so let's start right here. So she has X dollars. So she starts off with X. After spending, now, if we're spending, is that going to be a plus? Or is that going to be a minus type of situation? All right. I think it's going to be spending you're subtracting. So it's a minus situation. So that means after spending $90, so that's minus 90, she will have $45. So this is telling me what's left. So that's going to be my result. Right? So that's going to be my exact result. So when we're looking at this, do you do problems that a person can request? Sure. Do you know if you're still here? Yes, go ahead and request a problem. I would greatly put that in there. So if we have x minus 9, and I'm like, if it seems like I'm ignoring you guys, I'm really not. It's just the way my thing is set up. I can't see. I see there's a lot of hearts going, and I love it, and I appreciate it. But at the angle that I'm in, I think it looks like Amanda is doing it. Oh, yeah. Hi, Amanda. So it's kind of hard for me to see the screen and to do the math at the same time, but I am trying my best. But Dino, if you are still here, if you want to submit a problem, go right ahead. So now this is how you set up your equation. Maddie started with X dollars. She's spending 90, so it's minus 90. And she will have $45. That means that's what she will have left. So it's going to equal 45. So we want to know, what is the value of X? So what was the amount of money that she had originally before she bought the purse? So since it is X minus 90 equals 45, we have a subtraction. So if I go back, up to my inverses, I'm noticing that subtraction, the inverse of subtraction, is addition. So that means in order for me to get my X by itself, I would have to add 90 to both sides. Okay, so the inverse or the opposite of minus is plus. The reason why we want to do this is our goal. We want to isolate the variable. We want to get our X by itself of the equal sign. And whatever you do on one side of the equal sign, you must do on the other. So now negative 90 plus 90 gives me 0. It cancels out. But I don't need to write the 0 because I don't need the placeholder. But I will bring down its X as well as the equal sign. So now I just need to know what 45 plus 90 is. Okay, anyone wants to give a gander of what 45 plus 90 is? Hey, Slade. Always liked that name. Slade Wilson. Okay, so let's look at 135. Okay, 5 plus 0 is 5. 4 plus 9 is 13. Altogether will give me an answer of 135. All right. So breaking it down. Now sometimes the word problems will give you a little bit more detail. So what I mean by that, they will give you some other verbiage like increased by, decreased by, and you will be like, I don't know what to do with that. So inside of my Ultimate Math Notebook that I have created, I actually have a reference sheet. So this reference sheet shows the different words for addition, for subtraction, okay, multiplication, division, as well as equals and inequalities. A lot of students usually mix up the inequalities and like especially more than. More than for addition is more than for inequalities. Same thing with subtraction. Less than for subtraction is less than for subtraction. So I developed this notebook to help students, basically from 7th graders all the way up to adults, to kind of help with all the little areas that they generally keep missing in most assessments. So I have this a part of here, but let's continue on, whoops, with the lesson. So I want to do one more with addition and subtraction before I get to multiplying and dividing, because I want to give your brain some time to absorb what you're learning, so then it won't be too cumbersome. All right, so I have another word problem that I'm just going to fit down here. So we're just going to tape this bad boy in. Okay. And just to seal it. There we go. Okay. See, even clear tape, perfectly fine. All right. So some people like to have a full form, but it's not really necessary. All right. So this time we have John has X apples. Don't you love math problems that constantly refer to fruit? And then you're like, why does this man need so much fruit? All right. So John has X apples. If he adds 5 apples to his pile, he will have 8 apples. What's the value of X? And some of you are probably like, I think I know what it is before us even setting up the problem, which is great because mental math is key, especially when you get older, okay? Mental math is huge. So he has X apples. So we don't know how many apples that is right now, so we're using X. He adds 5 apples. So he's adding 5 to his unknown start of apples. And he will have 8 apples. So that means that equals 8. So now we have our unknown number of apples plus 5 apples equals 8. And you're probably saying, hey, Audrey, I think I know what the answer is. Awesome. Put it in the chat. I would love to hear it. Okay. And maybe we'll continue on and see if you are right. So we have X plus 5. That means it's a plus 5. It's a positive. And we need to do the inverse. So if I come back up here, my inverse of plus is minus. So that means in order for me to get this X by itself, I have to subtract the 5 on both sides of the equal sign. Remember, my equal sign is like my barrier. So now we have a positive 5 minus 5, which will give me 0. And I don't need to write that placeholder. I just need to bring my X down, as well as the equal sign. And then 8 minus 5, that gives me 3. So what's the value of X? So we're looking at 3 apples. Okay? All right. So slowly but surely, breaking it down step by step. So that was adding and subtracting. Now I want to kind of take a little bit with the multiplying, okay? I'm going to try to fit the division in, but I really want to get the multiply in because you see that quite often. So I'm going to go to the other side of my notebook. Oops. And just like we said earlier, see if I got that in here. Okay. So now we're going to be multiplying. So with us multiplying, the rule is the inverse of multiplication is division. Okay, so the inverse of multiplication is division. So if I give you, let's say an example, we're going to do a little bit of a combination. And we have 8x equals 56. So if 8x equals 56, if I look in between the number and the variable and I don't see a plus or a minus sign, that means I am multiplying. Okay, so that's how you tell if you're going to be multiplying or dividing. If you don't see a plus sign or a minus sign in between the a and the x, this is multiplication. Because as you can see with the stuff that we did earlier, we had a plus sign in between the 3 and the x. We had a plus sign in between the x and the 2. And we had a minus sign in between the y and the 8. Okay? So if we don't see a plus or a minus sign in between, that means we are multiplying. And the opposite of multiplication is division. So we're going to draw a line underneath, and then we'll take an 8 and an 8. So we always divide the number that is adjacent or next to the x, because the goal is still the same. We want to isolate that x. So if you think about it, not to cause you any kind of harm mentally, like think about it. You and your boo is together, and then all of a sudden your boo screws up and you got to divide them out of your life, right? I know, it just got real in 5 seconds. But that's basically what you're doing, okay? You're dividing, you're removing this person from your life and they're going to someone else's life, all right? And then you don't have to worry about it anymore. So when you divide, 8 divided by 8 gives me 1. It doesn't give me 0, it gives me 1. But I can just simply say x, because x and 1x means exactly the same thing. Okay, these two mean exactly the same thing. I'm actually going to write the word or in between so you can see it's going to be one or the other. So now we got your 56 divided by 8. This is one of those division problems that everybody's like, what is it? So it is going to be 7. Okay. So 1x equals 7 or x equals 7. This means exactly the same thing. Okay. They mean exactly the same thing. So when people are just like, oh, okay, 1x, now I have to divide both sides by 1. But guess what? If you divide both sides by 1 again, you're still going to get the same answer of x equals 7. All right. So let's try another one with multiplication. Let's say, actually, let me put it underneath here. So if I say 12x is equal to 144. So I have my 12x equals 144. So with my 12x, I need to isolate my variable. So I need to isolate my x. So the only way I can do that, since there isn't a plus or a minus sign in between the 12 and the x, I am going to divide the 12 out of my life. 12 divided by 12 gives me 1x, or just x. Okay, I like to put it that way. Then we have 144 divided by 12. That's a perfect square. If you get stuck, you're like, oh, Audrey, I do not have a calculator. I don't know what to do. Well, if I had my handy-dandy calculator or my handy-dandy notebook, I can go to 144, which is down here at the bottom. And my factors of 144 is 144, 272, 348, 436, 624. Okay, so there's a whole bunch of factors. But I want to see which one has 12. Boom, this one has 12. And it's saying 12, comma 12. So that means if I take this 144 and I divide it by 12, I'm going to get an answer of 12. Okay, same thing happens here. If I got 144 and I divide it by 9, I'm going to get an answer of 16. So this is how you can use this factor sheet to help you with your division as well. So if I say 144 divided by 3, it will give me 48. Or even vice versa. 144 divided by 36 will give me 4. But we're looking for 12. So 12 divided by 144 divided by 12 will give me 12. So here, my answer is going to be 12. All right. How are we doing so far? We do have a couple people in here. Good job. Hello, everyone. David Clark came in for a little bit. Amanda, thank you for being here. Appreciate you. Okay, Maria, welcome in. So, this was multiplying. Now we're going to get a little bit further. Yep, I'm not doing any, what do you call it? Yeah, that's just not my jam. All right, let me clip this bad boy in so it won't be all over the place. Now, the last part, and it tends to get to people, okay? It is still going to be multiplying. And then I will touch a little bit on dividing. But what happens if you have to multiply a fraction? So let's say, for example, let's say we have 1 over 7 x equals 3. And you're probably saying, ooh, that's a little advanced, Audrey. I'm like, it's okay. I'm going to walk you through it. You'll be all right. Okay? So we know that when you multiply, the inverse is going to be division. But when you try to divide a fraction, it looks funky. Like off to the side, it will look something like this. 3 divided by 1/7. That just looks like a stack of craziness, okay? We don't need stacks of craziness in our life. So when you are multiplying, because in between the fraction and the x, there isn't a plus or minus sign. But when you're multiplying with a fraction, I like to do this. I like to, and let's take it step by step, because there is an advanced step to this, but I want to take it to this level right now. You are going to multiply both sides. Let me switch colors here. So I'm going to multiply both sides by whatever the denominator is. So I'm going to put it like right here. Multiply by the denominator. Okay, so we want to multiply by whatever the denominator is. In this case, it's a 7. So when I multiply by the denominator, this is what's happening over on the left-hand side. So I actually have a whole number of 7 being multiplied by 1 over 7. Okay? When I multiply a whole number with a fraction, the numerators are going to be respected. I don't like using an x, but here we are. So that means we have 7 times 1, which gives me 7, over the denominator, which is 7. So 7 divided by 7, that's the equivalent of 1. Anything divided by itself is always equal to 1. And then this variable of x comes on down. And if this wasn't a 1, say it was like a 3, then you would have to do the division once again. You would have to do a two-step equation. So in this case, we got rid of that fraction because here's the shortcut. Anytime you divide by the denominator, they automatically cancel out. Okay, so you can skip this step right here after you get used to it. So once you divide, then you get your numerator with the variable. That's where the 1x comes in. So now that's the left side. So we got 1x. But what is 1x going to equal? Well, let's just multiply the 3 and the 7, which gives me 21. So the unknown variable that will make this statement true is going to be 21. Okay, so quick refresher, because I know that was a lot. Okay, I know it was. So we started off with 1/7 x. Since this is a fraction and it's being multiplied to the variable, we always want to multiply both sides by whatever the denominator is, which in this case was 7. That's where these two green 7s came from. Because whatever you do on one side of the equal sign, you must do on the other. So 7 times 1/7, the 7s cancel, giving me 1. And actually giving me 1x. Now on the right hand side, we're doing 3 times 7, which gives me 21. So since we just want to know what x is equal, that's how you know when to stop. All right, makes sense? Now these are a little tough, so I'm probably going to do another one like this tomorrow. And what I'm going to do is do this and do maybe a little more. I'm going to introduce division. So I'm going to do one more like this. Then we're going to do some more practice with this and division, because I do not want to overwhelm you whatsoever, because that's what happens when people get in the classroom. And that's probably what made you fear math in the first place, because everything was going so quickly, you didn't give your brain time to just marinate, right? So I'm going to put it up here, our next example. Actually, I should put it down here so it'll be easy for you to kind of use the previous problem. So we got our next example, and it is a over 9 equals 10. So a, an unknown number being represented by a, divided by 9 equals 10. So this time the variable is in the numerator. The variable could also be in the numerator for the previous one, but this makes it a little less convenient, a little less clunky. So we really want to get that 9 out from that denominator. So remember what we have to do? Multiply by the denominator. So on both sides, this time we're going to put it in red, just so you can tell the difference between one problem and the next. We need to multiply both sides by whatever the denominator of my fraction is. In this case, it is a 9. So 9 divided by 9 will give me 1. And we don't need just a 1, we need the 1a, or just a. So now over on the right-hand side, we get 10 times 9. 10 times 9, if you think of it this way, 9 times 1 will give me 9, and then add the 0 down, which gives me 90. Okay. All right. So how are you guys feeling? Okay. For the most part, pretty okay. I try to come on for like 45 minutes. I try to keep with the basics. And what I'm going to do for tomorrow, I'm going to do more with the multiplying and then introduce the dividing. Okay. Maybe do a little quick refresher with the adding, subtracting. So what we learned today. So if you were here earlier, I would have asked you, okay, during the lesson, how are you guys feeling? You know, for me, I was feeling pretty good. I hope so. And now that we're getting close to the end of the lesson, most important things that we need to know. We need to know our inverses. So for the formulas, I would like list the inverses. Let's see if I can slide that over. And then as long as we know that the inverses, I just like to rewrite it so it can in my brain. So if it's originally positive, that means I'm looking at negative, and vice versa. If my original is multiplication, and if you want to write multiply, or short for multiplet, it's going to be the inverse of division, just in case you don't remember your signs. All right. So when you go into it, the key, and I really want to write this down, the goal of solving. Oops. This is why I shouldn't write in pen. See, I'm already proving my point. So we want to isolate. It was a good run, right? We want to isolate the variable. That's our main goal. We want to isolate that variable. And if you're not sure what the variable is, I'm going to put an X. Okay? X means variables. Once you get into algebra, X does not mean multiplication. And I think if a lot of you guys have that drilled in your brain, you're really going to do well with math, because I think that's when it gets confusing. Once you start merging from traditional arithmetic to algebra, this is the part that really is hard to train our kids. They don't understand that X no longer means multiplication. Because if I ask them to, and I'm just going to put this as a side note, if I ask kids to say, all right, if I say 5 times X, this is what I generally see in my classroom. I'm like, why? What are we doing with the double X's? Yeah, we're not in the strip club. What are we doing? I have older kids, so it's kind of crazy. And this is exactly how they write it out. It's not 2 X's. Times no longer means an X. So this is completely inappropriate. So if you ever see any of your kids or anyone has an urge to do that, stop them. The way that you can write 5 times X is either 5X, or you can do 5 with a parenthesis, X. Majority of times you're going to see this way, more so than anything else. Okay? So that's something else that we might need to work on. And then especially we had a couple word problems, able to tape those in. So once we figured out that our goal is to isolate the variable and we're using our inverses to find that, that's basically the whole problem. And then on top of it, we did adding, subtracting, and then we looked a little bit into multiplying when it was just traditional, and then multiplying with the fraction. That was definitely challenging. So if you were kind of okay with this, that's awesome, considering this is probably your first time seeing it in forever. So I'm really proud that the fact that you're still here with that. So we're going to do more practice with this on tomorrow's session. And then we're also going to be doing dividing one-step equations. And I don't know, we might take a chance and do a little bit of combo just so we can make sure we understand how to solve an equation. All right, so if you like how I basically break it down, please do not hesitate to follow me. You can also contact me if you like the book that I'm using, my Ultimate Math Notebook. I do have it on sale. You can go to my website, which is the link in my bio, and you can click on that. This is for, I'd like to say, 7th grade all the way up to adults. We can do geometry stuff in here. We can do trig stuff in here. We can do some graphing. And this is the reason why I like the dots. I think my next book, I might just do just dots because I really do like those better. It seems a lot cleaner. It doesn't really affect too much the visuals. Systems of equations. I think I did something on that, or that is coming. Then we have the slope of the line, but this you can see, you can fit as much as you want. Whatever you can't fit on this side, we have the run over of the grid on the other side. Now, if you have a teacher that says, hey, I really want you to have this paper in your book, you can tape the paper in the book on one side, and then the other side, you can summarize what is on that paper. Because now you're actually practicing, you're learning. This is how you study math. You don't study math by just flipping the pages, okay? You actually have to, and this is what you could do. You can take your same piece of paper. You can copy down one of the problems onto that piece of paper. Then you take your notes, take them away. Then you solve your problem. And after you solve your problem, bring the notes back and then compare your answer. If you get the same answer, yay. If you don't get the same answer, now you can use your notes as an answer key to say, oh, that's where I screwed up. I forgot I didn't do blah, blah, blah. Okay? So that is going to be the way that's one of the ways that you can actually learn how to study math. And on top of it, as we've seen, I have my factor sheet and I have other resources to kind of help students out as a reminder. And the more further in the book you get, the more intensifies it gets. So now we're looking at trig and actually like the trig course functions. And if you ever have a kid that's going into Algebra 2, they're definitely going to see this lovely thing called the unit circle. I know you're probably like, what is that? It's okay. Okay, I'm here to break things down. All right, so have an amazing day. I will see you guys tomorrow. Same place, same time. I think I'm going to keep this time at 1 o'clock. And I might, if I feel really giddy, I might come again. I might just come twice. Why not? Why be selfish? Why just come on one time? All right. So I might keep the same 1 o'clock and I will see you guys tomorrow. All right. Take care. Have a lovely day.